Hi guys, welcome to the last day of law of sines, law of cosines. What we're going to do today is we are going to solve the last way of using law of cosines. It's when you're giving all three sides of a triangle and you have to find the angle. We're going to talk about that. Just quickly to review, what we've talked about this week is we talked about the first couple days. We talked about law of sines. Remembering that law of sines can be used with any triangle, normally a non-right triangle. And this right here is our sine equation, law of sines. Sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. And then looking over here to this triangle, we know that across from every angle measurement, which is designated by a capital letter, is the side length with the lowercase letter. Okay. Law of sines can be used when you're given any angle and matching side. But what happens when you don't have two of the same letters? You don't have a capital letter and a lowercase letter. Well, we talked last time how you would then use law of cosines. Law of cosines is given when you're given two sides and the included angle. The included angle is the angle between the two sides. Or, what we're going to focus on today, all three sides. The common way I always look at it is if I'm given A, B, and C, one of each letters, I use law of cosines. And then after I use law of cosines once, I then use sines from there on out. So law of cosines is always a one and done type thing. So last time we talked in video, we talked about law of cosines and how we said, yes, it is three separate equations. However, it's really the same equation. The side length squared equals the angle measurement. So like we said before, here's side A, here's angle A, and then the other two sides are added together squared, then multiplied by 2 times them multiplied together. The biggest issues with law of cosines is that people have a tendency to mess up order of operations, which causes their answers to get a little crazy. So just be aware that you're following order of operations. So last time we talked about, we found it when we had, like on number 1 right here, how we had A, side B, and angle C. And that C was our included angle, the angle in between those two sides. But what we're going to talk about today is what happens when you're given a problem like number 7. And instead of just finding angle A, we're going to find the entire triangle because I think it's important, and that's what we're asking you to do on your homework. So let's stay consistent. So here you're given, let's make this a little bigger and label our sides. Here's angle A, so this is side A, side B, and side C, okay? So you're given A, B, and C, one of each, so you can't use law of sines, you must use law of cosines. So we want to find what angle A is, what angle B is, and what angle C is. And we know little a is 14, little b is 9, and little c is 6, okay? So here's the most important rule when using law of cosines and given all three side lengths. You must find largest angle first. You must find largest angle first, okay? You must find largest angle first. This is so important. Okay, I'm going to highlight the whole thing. The largest angle is across from largest side. So the largest angle and the largest side are going to have the same, I didn't spell side right, hold on. They're going to have the same letter. So the largest angle and the largest side are going to have the same letter. So you have to find the largest angle first. If not, you get into a case where you have angle side side. And if you remember back to geometry, you could not use angle side side to prove triangle congruency because there's actually an option for there to be no triangle, one triangle, or two triangles. So that's why you have to find the largest angle first so you don't fall into the ambiguous case. Okay? So let's get started. So we're going to go back up. Here's our law of cosine equations, and we're going to go from there. So we're going to find angle A first because it's across from the largest side, which is 14. Okay, so here we go. So I'm going to get 14 squared equals 9 squared plus 6 squared minus 2, 9 times 6 cosine of A. Okay, so 14 squared equals 9 squared plus 6 squared minus 2 times 9 times 6 cosine A. Well, first thing I'm going to do is simplify things down, and this is where order of operation really starts messing people up. So 9 squared plus 6 squared, I get 117 minus 2 times 9 times 6, and that gives me 108 cosine of A. So most of you guys probably got to hear, you're like, okay, lever trick, I'm pretty good. This is where it's going to get tricky. People are going to want to do that first. They're going to want to subtract 108 from 117. No, because that 108 is multiplied by that cosine. It would be like a negative 108 times x. We would not subtract, if we had this problem here, we would not subtract these two first. We would move the 117 and then divide by the 108. That's exactly what you're going to do here. So I'm going to move the 117. So I do 196 minus 117, and I'm left with 79 equals negative 108 cosine of angle A. Now I'm going to divide by negative 108. Okay? So that's really the hardest part, is that people really mess up that first part there. Just take your time with it. Remember back to order of operations. And I'm doing 79 divided by negative 108. And I'm left with a longer decimal. I want to write down at least 3 or 4 of those, kind of like before when you're doing cosines. The more numbers you write down, the more exact you're going to be. So I'm left with this. And that's going to, of course, be negative. So I did about 4, I did 5 numbers after decimal if you do 4, but really try to avoid doing 1. Now I want to get rid of cosine, so I can't divide by cosine, that's not a thing. So what I'm going to do is multiply everything by the cosine inverse. We've done this a lot, and so we end up with A equals the cosine inverse of negative 0.73148. Again, the more answers you get, the more exact your answer will be, or close to it. So we're going to do the cosine inverse. Reminder, make sure your calculator is in degrees. If it's not in degrees and it's in radians, it's going to give you the wrong answer. We're going to talk about radians starting next week. And I get A is 137.01. We round angle measurements to the nearest whole. So my angle A is 137. I'm going to solve for this entire triangle though, so I got 137. Well, now I have to go into law of sines and find the next one. I like to always go with the biggest, so the next biggest one that I have left there is going to be B. So I'm going to find B next, okay? Angle A and side A are going to be my given, and then I'm finding angle B. So let's move this over, and let's find our B. So I do sine of 137 over our angle, our side length was 14, equals sine of B, because that's what I'm finding, over the measurement of side B was 9. So again, you only use law of cosines once, then you go straight back in law of sines. You should be really good with law of sines by the end of this unit because you do it over and over and over again. So I'm going to cross multiply sine of B. I tried to do it backwards. Then I'm going to divide by 14. And I'm going to flip it so I get sine of B equals 9 times sine 137 over 14. And again, it's not such a thing as dividing by sine. but I can multiply both sides by the sine inverse. And I distribute it to both. So I get angle B equals the sine inverse of 9 times sine 137 over 14. And again, the biggest error made here is that people are going to try to type all this in at once in their calculator, and then their answer is going to be off. So again, just to recall, I like to do the numerator first. So 9 times sine of 137, enter. Divide that answer by 14, enter. And then take that entire answer and put it into the sine inverse. And I get 26.0035, so angle B is 26 degrees. So I'm going to come on over, and now I know B is 26. Okay. I could use law of sines again, but that's really going to be too much trouble. Okay. We don't need to use law of sines again, because to find angle C, we know that a triangle equals 180. So we're going to do 180 minus RA, which was 137, minus 26, and that's going to give me my C. So I do 180 minus 137 minus 26, and I get C is 17 degrees. So I come over here, and I put C is 17. 137 plus 26 plus 17 equals 180. So I know I have the correct angle measurements at least because they equal a triangle. So that's it. So there's law of cosines. Again, you use each one of them once, and then you go straight back into law of sines. If you have any questions, feel free to get on Zoom. This assignment is due Sunday by midnight. And then next week we're going to get into radians. So I keep telling you, get your calculator in degrees. Radians and graphing and the unit circle. We're going to kind of jump into the next part. Have a great day and talk to you guys later.